Hello class, welcome to another video lesson. Today we're talking about factoring. It's 5.4, and as you can see on the smartboard presentation it says 5.4 factoring review. This is a review because you guys have all done this before. I believe in intermediate algebra you guys have done many practice problems on factoring. And the reason why you've done it so many times, and the reason why you're going to do it again today, is because factoring is huge in math. We do it all the time. Not only in chapter 5, but you're going to see it in chapter 6, chapter 7, chapter 8, and chapter 9. And so we need to get that fundamentals of factoring down so that we can apply it to our other chapters that are going to be coming up. And then not only in this class, but you're going to see factoring on your MCA tests, you're going to see factoring on your ACTs, in every college class that you take. Basically, every math class that you're going to take from now until the day you die is going to have factoring in it. So we need to make sure that we learn and understand how to do it. So there's 3 strategies that I want you to get as we start off. Actually, kind of 4. The first one, make sure you always take out a greatest common factor. That's going to be the first step with any problem that you see. So if you see something like 3x squared plus 6x minus 9, the very first step is to always take out a GCF. So if these 3 terms each have something that is the same in them, a factor that is the same, you pull that out in front. And as you can see, 3, 6, and 9 are all multiples of 3. So the greatest common factor would be 3. You take out a 3 from the first term, and you're left with x squared. You take out a 3 from the second term, and you're left with 2x. You take out a 3 from the third term, and you are left with a negative 3. So that's what it means by always take out a GCF first. Then the second thing, if there's only 2 terms, what should come to your brain instinctively is think if it's the difference of 2 squares. And we're going to have a couple examples on that in our notes for today. So if it has 2 terms, think of the difference of 2 squares. If it has 3 terms, think of factoring. And the way that you're going to factor these is just by guessing and checking. Here's the great thing about factoring, class. You could try something, and if it doesn't work, oh well, that doesn't matter, you just try again. It's not like you fail, you just try again. Thomas Edison, when he was inventing the light bulb, he tried, his quote is this: "I have not failed, I've only found 10,000 ways how not to make a light bulb." So evidently he tried something, didn't work. Tried something, didn't work. Tried something, didn't work. Not that he failed, it's just that he found one more way not to make a light bulb. But it only takes one to work. So make sure that as we're factoring these, when you see 3 terms, you're just going to try a whole bunch of different possibilities until, boom, you find one that works, there's your right answer, you move onward. 4 terms, in my opinion, this is the most difficult one. You factor by grouping. We're going to have 1 on our first page of notes, and I believe we have 1 or 2 on the back of our notes as well. So make sure that we pay attention to those. So those are our strategies. So let's talk about number 1. We have x squared plus 7x plus 12. First step, we take out a GCF. Is there anything that we can take out of x squared, 7x, and 12 that we could pull out in front? Hopefully you say no, there's nothing that we can pull out in front. So now the next thing we think of is that it is 3 terms. If it is 3 terms, what is our strategy? Our strategy is to factor by guessing and checking. So here's what you do. We have 3 terms. Instinctively, immediately, maybe is more what I should say, I'm going to form 2 parentheses. Hopefully this is starting to look familiar to most of you. After I have these 2 parentheses, I know that my first term is x squared, and the only factors of x squared are x multiplied by x. So I know in the first term of both of these binomials is x, because when I FOIL, I'm going to have the first times the first, which is x times x, giving me x squared. Now, in this spot and this spot, I need to have factors of 12. So my factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So in my second 2 spots that are in my binomials, I need to have factors of 12, and then the tricky part is that when I add them up, I have to get the middle term, which is a 7. So I need to have 2 factors of 12 that add up to give me 7. So as you can see, this would add up to give me 13, this would add up to give me 8, and this would add up to give me 7. So as you can see, I have found my winner. My winner is the factors of 3 and 4, which give me 7. So I'm going to have a positive 3 right here and a positive 4 over here. You also could have the positive 4 in this spot and the positive 3 in this spot. It doesn't matter the order. You could have either one. But here's what I mean by checking, class. What I always want you to do on these ones is I want you to FOIL. So what we're going to do is we're going to FOIL by taking first times the first, outside, inside, and the last. So we have x times x to give me x squared. X times 4 is a positive 4x. 3 times x is a positive 3x. And 3 times 4 is a positive 12. So now, when I combine like terms, I get x squared, 3x and 4x make 7x plus 12. So as you can see, what I start off with, x squared plus 7x plus 12, is exactly what I get when I FOIL my two binomials of x squared plus 7x plus 12. So now I know with 100% certainty that my answer is these two binomials multiplied by each other, x plus 3 times x plus 4. This is factoring by guessing and checking. You're just going to try a whole bunch of different possibilities until you find one that works. And once you find one that works, check your answer. Once you check it, you know that you have the right answer and you can move on to the next one. So let's try again. Number 2, once again, I cannot take out a greatest common factor. So when that's the case, I think 3 terms, I'm going to factor by guessing and checking. So I'm going to form my 2 different parentheses. Once again, my first term is x squared, and my only possibilities in my first term of my 2 binomials is x times x, because those are the only things that make x squared. And now I have a negative 15. So I have to think of factors of 15, such as 1 times 15 and 3 times 5, that are going to give me a 2 in the middle. And as you can see, this is a negative 15. So factors that give me a negative 15, one has to be positive and one has to be negative, because a positive times a negative is a negative number. So I'm just going to put a positive in one spot, a negative in the other one. So now what you could think of is factors of 15 that when you subtract them are going to give you 2. Which 5 and 3 is going to be your winner, because 5 minus 3 is 2. So that must mean that the 5 has to be the positive number and the 3 has to be the negative number. This is your answer. Always make sure that you check. And oftentimes when I check, I basically only check my middle 2 terms, because I know that in FOIL, the first and the last, the F and the L, are very easy to check in your head. X times x is x squared, and the last term, 5 times negative 3 is negative 15. So now I just want to make sure that my 2x works for my middle term. I want to make sure that this checks out. So I'm going to have a negative 3x and a positive 5x, 5x and a negative 3x. Sure enough, that does give me 2x, which is what I need right here. So I know that x plus 5 times x minus 3 is indeed my answer. And I move onward. Number 3, 2x squared minus 13x minus 7. I see if I can take out a greatest common factor. Once again, I cannot. So now I see a trinomial. I'm just going to form 2 different parentheses. Now on the first 2, when I had a coefficient of 1 right here, it was 1x squared on both of them. That was pretty simple. I could just go x multiplied by x. Factoring becomes significantly more difficult when you have a coefficient other than 1. As you can see right here, I have a coefficient of 2. So now I got to think of factors of 2 that are going to be in my first term of my binomials. My factors of 2, there's only one pair. It's just 1 multiplied by 2. Guess I didn't need parentheses there. It's just 1 multiplied by 2. So that must mean I have to have 2x in one and 1x in the other, because 2x times 1x is 2x squared. So now that I have that, I have to think of factors of my second term. And that's going to be this negative 7. And I know that factors of 7 There's only one pair again. It's just 7 multiplied by 1. So now I have to think of those factors when I add them up are going to get me this negative 13x in the middle. And that can be kind of tricky. You have to understand that one of those factors is going to be multiplied by the 2 as well. That term right there. Because obviously the O and the I in FOIL is the outside and the inside terms. You multiply them by each other. So if I just think in my brain right now, I'm thinking 7 times 2 is 14. That's going to get me really close. So if I have the negative 7 right here and the positive 1 right here, I'm just trying a different possibility to see if this is going to give me my answer. So now I'm going to guess and check by foiling. First times the first. 2x times x, 2x squared. 2x times a negative 7 is a negative 14x. 1 times x is going to be 1x, and 1 times a negative 7 is a negative 7. So now I combine like terms. 2x squared. A negative 14x plus 1x is a negative 13x. Subtract 7. Is that what I started off with back up here? 2x squared minus 13x minus 7. Because I foiled this and got right back to my original, I know with 100% certainty that this is my answer. 2x plus 1 times the quantity x minus 7. Hopefully this is all starting to come back to you and this lesson isn't very difficult. Certainly let me know if I'm going too fast or if you need any more help when you guys come back to class again tomorrow, because I could definitely do some more with you. But I think a lot of you have a good grasp about what is happening here. All right, number 4, 6x squared plus 7x minus 20. As you can see, these are getting more difficult with each and every problem. The reason for that is because I'm starting to get more possibilities with my coefficient in front of my x squared. In this case, it is a 6. So my first step, is there a greatest common factor I can take out of 6x squared plus 7x minus 20? There is not. So now because it's a trinomial, I'm going to form 2 different parentheses. The first term in the binomial are factors of 6x squared. So that's going to be 1 times 6 and 3 times 2. So I just have to basically just try one of them and see if it works. This is what I mean by guess and check. So I'm going to try a 3 right here and a 2 right here. And not only a 3 and a 2, but a 3x and a 2x. Again, the reason for that is that when I FOIL, my first times the first, 3x times 2x has to get me a 6x squared, which indeed it does. All right, and now I have factors of this third term, 20, which is 1 times 20, 2 times 10, and 5 times 4. So one of those factors, when I multiply one of them by the 3 and multiply the other one by the 2 in this 3x and 2x, has to get me a positive 7x in the middle. So with these possibilities, class, I just encourage you, try. If it doesn't work, that is okay. All you do is you just take your eraser on your pencil, erase, and try again. So it's not a terrible thing to try and fail. It is a terrible thing to try and fail and then give up. That is terrible. But to try and fail, it doesn't matter if you fail because you can just try again 10 seconds later. So let's just try one. Let's try, how about a positive 4 over here and a negative 5 right here. I know that I have to get a positive 7x, so now we're just going to try. A negative 5 times a negative 4 is a negative 20, so we're good there. And 3x times 2x is 6x squared. So now I just got to try this 7x. Here we have a positive 12x, and here we have a negative 10x. So if we have 12x and a negative 10x, that's going to give us a positive 2x. Did I need a positive 2x? Nope, I needed a positive 7x. So guess what, class? I did it wrong, and that's okay. All you do is you just erase and say, well, positive 4, you are not the one. Negative 5, you are not the one. That's the worst that can happen in this, is that you just have to try again. So let's try something else. Let's try the positive 5 right here and the negative 4 right here. Let's see if that gets us our winner. If we FOIL first times the first, we still get 3x times 2x is 6x squared. Let's do the last term too, just to check it. A negative 4 times a positive 5 is indeed a negative 20. So now I just have my O and my I of FOIL, my outside and my inside. So we're going to have 15x, and I have a negative 8x. What does 15x minus 8 give me? It gives me 7x. And I have my winner. I needed 7x to go with this 7x. So I now know, once again with 100% certainty, that my answer is 3x minus 4 times the quantity 2x plus 5. Class, I hope that foiling is somewhat, at least I hope that you're successful with it, because you can check your work on every last one of these. And it doesn't take long to check your work either. So I should hope on this test, hopefully you get all of the factoring ones right, because all you have to do is check your work, and it doesn't take very long to do it. Number 5. This one hopefully looks a little bit fishy to you. You only see two terms. You see x squared and a negative 64. When there are two terms, go back to the top of the notes. What are you supposed to do when there are two terms? You should think the difference of two squares. So we start off by making two parentheses. I know that the difference of two squares always has a positive in one and the negative in the other. I have x squared, which is a squared term. It is x times x. And then the second term is a 64. 64 is also a term that is squared. That squared term is 8. 8 times 8 is 64. So we're going to have a positive 8 right here and a negative 8 over here. Now once again, class, I encourage you to check your work. If we were to FOIL this, first times the first, x times x is x squared. Outside, x times a negative 8x, or sorry, x times a negative 8 is a negative 8x. Inside, 8 times x is a positive 8x. And last, 8 times 8, 8 times a negative 8, is a negative 64. So what do we have when we combine terms here? Combine like terms. X squared, a positive 8x and a negative 8x cancel out to make 0 x's, minus 64. Is this what we started off with? X squared minus 64, x squared minus 64. So this is an example of the difference of two squares. Whenever you see the difference of two squares, it's basically the same binomial, except for one change. One has a positive sign and one has a negative sign. So just to get you a little bit more comfortable with that, if you were to have something like x squared minus 49, instinctively, just form two parentheses. Go x minus 7 times x plus 7. It really is just that easy. Make sure that you get the square root of this number, which is x, x times x, and get the square root of this number, which is 7, have one be a negative and one be a positive. If you have something that looks like this, maybe 4x squared minus 1. It has two terms, and this is the difference of two squares. Two different parentheses. You have the square root of this term, which is 2x. 2x times 2x is 4x squared. Is 1 a perfect square? Yes, 1 times 1 is 1. So we're going to have a negative 1 right here and a positive 1 right here. So whenever you see the difference of two squares, not too difficult. All you do is make two different parentheses, take the square root of both terms. The square root of the first term goes here and here. The square root of the second term goes here and here. One of them is positive and one of them is negative. We'll have another example problem, I think, as we go on. Yes, right here. We have two terms. As you can see, when we think of the difference of two squares, 2 isn't a perfect square, nor is 32. So now you might think that we're stumped. But our very, very first step in factoring is see if you can take out a greatest common factor. 2x squared is an even number, and a negative 32 is an even number. So if that's the case, they both have a factor of 2 in them if they're both even. So I can take out a 2, and now I'm left with x squared minus 16. Now does this look like the difference of two squares? Just focusing on this blue part. Hopefully you see that it is. X squared is a perfect square, it's x times x, and 16 is a perfect square, it's a positive 4 times a negative 4. So with that being the case, we're still going to have 2 on the outside with 2 different parentheses. It's going to be x times x, and then 16 minus 4 and a positive 4. And there is our answer for number 6. 2 times the quantity x minus 4 times the quantity x plus 4. Number 7, 2x squared minus 10x minus 48. Hopefully you see once again that all of these are even numbers. So let's take out a greatest common factor of a positive 2. Taking out a 2, we're left with x squared minus 5x minus 24. At this stage, sometimes what I often do is I check my work just to make sure that I took out the GCF correctly by distributing this to get right back to my original. 2 times x squared is 2x squared. 2 times the negative 5x is a negative 10x. And 2 times the negative 24 is a negative 48. So I know that I took out my GCF right because when I distribute it right back again, I get back to what I originally started off with. So now that we have that, we have this trinomial. This trinomial, you should think factor by guessing and checking. So we're still going to have the 2 on the outside, and then we're going to have 2 different binomials for the x squared minus 5x minus 24. For my first term, x times x gives me x squared. And for my second terms in my binomials, factors of 24 that get me a negative 5. I know 8 times 3 is 24. And I need the 5 to be negative. So that must mean the bigger number should be negative. So it's going to be a negative 8 and a positive 3. Let's just make sure really quick. X times x is x squared. Good there. A negative 8 times a positive 3 is a negative 24. Good there. So now we're just worried about the negative 5x. Which if we have our outside, x times 3 is a positive 3x, and inside, a negative 8 times x is a negative 8x. So 3x minus 8x does give me the negative 5x that I need right here. So I know that my answer is 2 multiplied by the quantity x minus 8 times the quantity x plus 3. Number 8, this time you see 4 terms. Hopefully your eyes popped open a little bit wider because this is something that is very, very different than what we've seen on our notes for today. So if we have 4 terms, if you go to the top of your notes, you see that when it's 4 terms, your strategy is factor by grouping. So here's how this works, class. When you factor by grouping, what you want to do is you're going to take the first 2 terms and group them. And take the second 2 terms and group them. So we have x plus 3 in one group and x cubed plus 3x squared in another group. So now all you're going to do is take out the GCF in the first 2 terms and take out the GCF in the third and the fourth terms. So what can you take out of x and a positive 3? Hopefully you say that there's nothing that you can take out of x plus 3. So we're just going to keep it as x plus 3. And we're grouping them, so I'm going to put a parenthesis around that. Now, what GCF can you take out of the third and the fourth term? What does x cubed and 3x squared have the same as far as factors are concerned that I could take out in front? Hopefully you see that an x squared can be taken out of both of these. If I take out an x squared, if I take an x squared out of this, the only thing that's left is an x. because x squared times x is x cubed. And then if I take an x squared out of this one, all I'm left with is the 3. So now I have this positive 3 right here. And what you took out for this greatest common factor is a positive x squared, so I'm going to put a positive number right there. All right, now here's the next thing that you do. You have this x plus 3, and you have this x plus 3. So you kind of made these 4 terms, 1, 2, 3, 4, you made 4 terms into 2 terms. Here's one term, and here's the second term. So with this, you're going to take out another greatest common factor. Is there any factor that is the same between x plus 3 and x squared times x plus 3? Hopefully you see that this x plus 3 is the same as this x plus 3. So you can take this x plus 3 and this x plus 3 out in front. Let me show you what I mean. If I take out the x plus 3 out in front, after I've done that, what is left from this term? Hopefully you see that you took out the whole thing, so what is left? Don't say 0. What is left is a positive 1. This is 1x plus 3. So if you factor out an x plus 3, you still have this 1 left over. How about this term? X squared times the quantity x plus 3. After factoring out this x plus 3, what is left over? This x squared is. So you still have this positive x squared. In class, there is your answer. On a test, I would be perfectly happy if that's what you left your answer as. I'd give you full credit. On Excel math, you probably won't see your answer like this, just because oftentimes with this binomial, they have the variable first. So instead, they might have x plus 3 times the quantity x squared plus 1. So either of these two answers would work for me on the test. Now this could be kind of confusing. You might be asking, Mr. Berge, is there any way I could check my answer to know for certain if I have the right answer? And the answer to that question is yes, you can do that. Just by foiling, first, outside, inside, last. So watch me foil. Class, you don't have to check your work, but I certainly recommend that you do. First times the first, x times x squared is x cubed. Outside, 3 times 1 is a positive 3. Inside, 3 times x squared is a positive 3x squared. And then I would have, what did I do here? Something is fishy. Let me start over. Okay, foiling. First times the first. X times x squared is x cubed. F-O. O stands for outside. X times 1 is a positive x. Inside, 3 times x squared is a positive 3x squared. And last, 3 times 1 is a positive 3. That looks better. Let's put this into descending order. So I would start off with my x cubes. I would have 1x cubed. Then go to my x squared. I have 3x squareds. Then go to my x's. I have 1x. And then positive 3. I foiled my answer. And when I foil my answer, if I get right back to what I originally started off with, I know with 100% certainty that I did it right. X cubed plus 3x squared plus x plus 3, boom! X squared, sorry, x plus 3 plus x cubed plus 3x squared. I'm really butchering this problem, but as you can see, 1x and 1x. Positive 3, positive 3. Positive x cubed, positive x cubed. Positive 3x squared, positive 3x squared. So if your question was, can I check my work when there's 4 terms? The answer is yes. All you have to do is FOIL. Let's do this last one, and then I'll call it quits for this video because evidently I'm getting crazy. So we have 10x cubed plus 15x squared plus 175x. If you look at this one, the very first thing you should think of is, can I take out a greatest common factor? Is there a factor that is common between 10, 15, and 175? Hopefully you say yes. Hopefully you say 5 can be taken out of all 3 of those. And 5 can be taken out of all 3 of those terms, yes, but that's not the greatest common factor, because you could also take out an x out of all 3 of these. So 5x is our greatest common factor. So after we take out the 5x, what do we have left? We have 2x squared, a positive 3x, and a positive 35. If you want to check your work at this point, all you have to do is distribute this 5x into each of those 3 terms, and you'll get right back to your original. Now that you have that, you have this 2x squared plus 3x plus 35 right here in blue. You want to see if you can factor this one as well, and having this 5x out in front. Because this is a trinomial. Whenever you think of trinomials, you should always think of factoring by guessing and checking. And here's the deal, class. You can try to factor this until you're blue in the face. It will never, ever, ever work to be factored. You can try 2x and 1x and a positive 7 times a positive 5, which gives you 35, but it doesn't give you 3x in the middle. So there is no possible way that you can factor this trinomial. So the only factoring that you can do in this case is to take out the GCF. So your answer is right there. 5x times the quantity 2x squared plus 3x plus 35. That is as far as you can go there. All right, here's the deal. I've done enough talking. What I want you to do is turn over the notes, and you're going to try problems 10 through 18 all on your own. Try to factor these as best as you possibly can. Check your work so that you can know for certain that you're doing it correctly. You're going to have difference of 2 squares. You're going to have factoring by grouping. You're going to have trinomials. I want you to give it a shot on your own. So really try these on your own. I'm going to record another video that's going to have all of the right answers on them. So try your best. Best of luck to you.